All right, guys, I'm going to do a before and after. So this is the before. This is the vacuum table and plenum design of the current table. And then with the help of All Star CNC, we have worked out a new system, which I hope, fingers crossed, is going to be much better. The problem is on a downdraft table like this, it's basically taking the atmosphere and it's pulling the atmosphere through the table and sucking it out. When you try to hold small parts, it just doesn't work. There's not enough power, if you want to call it that, to hold it down. So once I learned about the differences between them, I am super excited. It's costing me a lot of money to change all this stuff. But when I cut those foam parts out, for this manufacturer, these are roughly 6 by 6 inches, and this foam weighs almost nothing. I ruined a couple parts because of the hold down or lack thereof. So that got me invested into looking into a solution for this. So let me give you a quick rundown. Obviously you can see I'm doing stuff on here. So it's just an MDF spoil board with an MDF plenum as well. Hurricane black box to the piping underneath, nothing fancy, standard. And this is as edge banded and painted. I'll throw up a picture of what it looked like. I did not put gasket in here because I did not know I needed to. So according to All Star CNC, using the MDF as the plenum board, I'm getting a lot of vacuum leakage because it's not gasketed. So what I'm switching to is HDPE. So I have this sheet here. This is going to become the new plenum board. And that is non-porous, meaning air cannot go through it, so it should be a better system. The other problem is these locating pins. I had a person 3D print me these, which are great because if you accidentally cut into them, it's just plastic, so it's not a big deal. But if I can zoom in on that guy down there, if it'll focus, you see how that's off kilter. So even though these holes were precisely drilled and fit with the CNC, over time, more and more use, these have wallowed out ever so slightly because they are MDF, and you know it just, they wobble in here. It's not a perfect alignment system. So what I have done is purchased pop-up pins, pneumatic pop-up pins. So we'll get to plumb that in. You'll see that, and I won't have as many. I think I bought 7 of them. So I think I have 4 on this side and 3 on this side. The reason why, and I'll show you design, I like this layout because I cut a whole bunch of different stuff. It's a, we're a custom shop. So I might have a small piece like this I'm cutting out, and I might have a full sheet of the next something else I'm cutting out. So I like to be able to move these as needed, because if you have a pin here and you have a pin all the way up here, well, now I don't have a pin for this board, I only have one. So you can work around that, but you see it makes it difficult to get this properly aligned. So again, I'll show you design, but I kind of strategically placed them where I think it's like anything larger than like a 12 by 12 piece will work with the pneumatic pins. Okay, so I want to turn the vac on and see if we can hold this part down. So we're under one zone, which is this 2 foot by 4 foot zone. So it goes 2 foot wide up to 4 feet. And I guarantee it's not going to hold it. So as you can see, that's the problem that I'm currently having with that much air leakage through this system not being gasketed. Talking to All Star CNC, this is the problem. Something like this, I cannot vacuum this down. I cannot hold this. So if I were to cut this, I have to use the traditional methods of using screws or double-sided tape or obviously something else. So the investment into the vacuum system appears really great at first because you see what other people are doing with it. However, I've quickly realized these limitations to the system when you don't have it set up properly. So I'm very excited to show you guys how it's going to be after it's all set up. Is where we are at after a tremendous amount of work. So I got obviously the HDPE sheet all cut down. It took me a very long time to figure this first pin out, because if you have a CNC, you understand that the spindle and the bit can only travel to a certain location. It can't travel all the way over here. And conversely, it cannot travel all the way over here. So I'm trying to find where to locate this pin in reference to, you know, where this has to mount in here to get the maximum amount of travel. And after messing with it for the better part of all day, this is the location I have settled on, which gives me a cut width on the X of 48 3/4. So unfortunately, I lost about a 1/4 inch. And I lost a 1/4 inch because this extrusion, it's kind of hard to see, but it goes to basically right where this block is. And on my old system, since it was MDF, I was able to go out further to the edge. Since I wasn't drilling all the way through, I didn't hit that extrusion. It pops, pins pop. We're going to be using grid tile from All Star CNC. So I've went ahead and flattened this on one side already. This is LDF, light density fiberboard, so it's even more porous than MDF. This is going to be the new spoil board, and it's going to have All Star CNC gasketing, tile gasketing on top. So this adhesive material gets peeled off and it gets put directly on your spoil board and actually becomes your spoil board. So this is a consumable product. You will cut into this just like your spoil board. But what this product does is it seals off 85% of your spoil board and only allows 15% of your vacuum pressure to come through these holes. So what this is going to actually do is take the air out and take the atmosphere out from that part, and it's going to actually clamp it, vacuum clamp it, instead of just using downdraft. All right, guys, been hard at work today. Got the grid gasket up from All Star CNC. Check out my previous reel. I'm freaking speechless. I cannot, I'm at a loss for words. Just check it out. Hold down power is absolutely incredible. And that was with the MDF. Now I want to do a test with the tile gasket. All right, I'm going to turn the pumps on, and we're running one zone, and I'm running both primary and secondary on the Black Box Hurricane. This is a 4x4 coaster. So that is using a significant amount of my strength to be able to move that 4-inch by 4-inch coaster. I'm telling you guys, I'm blown away. This is incredible.